name is Norliana binti Ahmad Sukri with registered number AD170113. So I would like to present about our chapter 1, Introduction. This is our product background. The lack of a consistent source of potable water is one of the largest issues facing the developing world today. Over 844 million people lack basic drinking water, and it is projected by 2025 half of the world's population will be living in water-stressed areas. According to UNICEF, women and girls worldwide spend an estimated 200 million hours daily retrieving water for their families. By improving admittance to safe drinking water can result in substantial advantage to health. Further, purification will allow a family to access clean water during day considerably faster than before, reducing the stress involved in accessing drinking water in small towns. Next one is problem statement. Just 0.3% water on Earth is fresh water, while 98.5% of Earth's fresh water was found underground in aquifers, which are safe for drinking. Groundwater appears to require less purification, but freshwater is more readily available above ground. Due to this water disruption, many residents as well as SFE are facing hard time during this period as it happens very frequently. Therefore, we have considered to make a product with a solution where we design a pedal-operated water filtration which can filter water by using human muscle power via pedal-operated mechanism. Firstly, to design an efficient design of pedal-powered water purifier system for residence area. Secondly, to develop a product with an affordable price and safe to use. Thirdly, to provide compact in size for use and low-cost water purifier machine. And lastly, to decrease the contamination of water and process positive impact on health. Our project scope is, there are three project scopes. Firstly, to supply purified water for villages and remote places. Secondly, to fabricate a filtration system by pedal power. Thirdly, to analyze the design with relevant engineering analysis. Then, our project significance consists of two main points. Firstly, reducing the burden of drinking water in developing countries. By pre-existing bicycle infrastructure and local freshwater service will ensure residents to purify their own drinking water by using their human energy. Secondly, the product introduced in this study will help address this drinking water problem. It consists of water purification system that can connect to any bicycle and utilize power by the users to draw water.
So for the chapter 2, under customer requirement, when after we made the survey by Google Form, we get the feedback from the customer and we list the customer environment. As we can see from the table, the view is number 5 is strongly agree, number 1 and 2 are strongly disagree. So for the design, most of respondents like agree with space saving. However, for the cost, mostly average respondent. For the safety factor, mostly prefer hard to be stolen. Moreover, the quality factor, most of the customer agree with can provide clean filter water for user. And the function, mostly customer prefer required minimum works to operate and can be operable by all.
A very good day to our Design 2 lecturer, Dr. Badrul, and I am Sathis Rajah, mentic number AD170186, and today I am going to present the chapter 5 and 6. Okay, for our simulation, we have done two types of analysis using SolidWorks Simulation 2019 on our product. Those are static analysis and also buckling analysis. Under static analysis, we have obtained four types of analysis, which is stress, strain, displacement, and also factor of safety. Okay, this is the first object we use. This is the second object, and this is the third object. For strain, and this is for displacement. For the factor of safety, for the first object, we obtain minimum factor of safety of 0.6. For the second object, we obtain minimum factor of safety of 26. For the third object, the minimum factor of safety is 1.3. Okay, this is the buckling analysis for the first product. This is the second product, and this is the third product. Okay, that's all from me. Thank you.
Hello, my name is Moviyndiran from the group Mechboom. I'm here to explain about our system's working principle. As we've seen here, our system contains an open tank, storage tank, peristaltic pump, and two filters, which is carbon and reverse osmosis membranes. So an operator will sit on the seat and pedals, and the motion is transferred by the pedal crank to the rotor and thus to the rollers. To move the fluid, the tube is compressed by a set of rollers. Once in the pump, the liquid is pushed through the tube by compressing the tube at a number of points in contact with rollers. The fluid is moved through the tube with each rotating or oscillating motion. The water is then forced through carbon filter and reverse osmosis membranes. The carbon filter will remove or reduce impurities and contaminants such as chlorine, sediment, volatile free organic compounds, poor taste, and odor from water. The reverse osmosis membranes will remove viruses, bacteria, and parasites. The purified and filtered water is delivered to the storage tank. Thank you.
A good day to my panel. My name is Sethupathi Saravanabava from section 4, and I'm here to talk about chapter 7 and 8 for my project. So, as you can see, chapter 7 is about sustainability and environmental consideration in engineering design. The basic concept is the sustainability of the item, or to consider the advantage to shopper and the critical thing it's towards nature. This is a key point to see whether the items that have been created and delivered are adequate. So, the elements in sustainability are social, economy, and environment. Sustainability is a term that has come into popular culture as a characteristic of national fiscal policy, personal budgetary policy, and environmental policy. Now, as you can see, this is the table for sustainable development. It shows the correlation between the economic growth, social progress, and environmental stewardship. Now I'm going to move on to chapter 8, which is the cost evaluation for our business plan. As you can see in the table below, it is the cost evaluation for the direct material cost, which is the fixed variable of the project. So as you can see in the table, the total for our fixed variable is 480 ringgit. The fixed cost, sorry. Next, we move on to the overhead cost, which is the variable cost. In our case, the variable cost is only for welding, which is 50 ringgit. So the total is 50 ringgit. So first we have calculated the total cost, which is fixed cost plus with the variable cost times with quantity. And down here you can see that the TC, which is the total cost for making our per unit of our project, is 540 ringgit. Then we have calculated our profit. The selling price is fixed at 685 ringgit. So, and minus the manufacturing cost, which is 540, we get RM 145 for per unit. Thank you very much.